existing boiler and you go in and you put a new boiler in, how do you figure out if you've got the correct one going in? And what are we going to start talking about? Biggest thing we're talking about is BTUs. The amount of energy required to raise 1 pound of water 1 degree Fahrenheit. That's a BTU. It is basic. It is back to the very basics. And this is what all of our heating and cooling systems work on, is sizing by BTUs, British Thermal Units. So there's three methods of boiler sizing. The first, the most popular one, is the fingers method, where you stand across the street, hold your hand up in front of your face, and however many fingers it takes to cover that house is how many boiler sections are required. They laugh at that one, but it's been done for a lot of years. And if you Google the finger method of heat sizing, it actually comes up. Kind of scary. The second one is the swag, the scientific wild guess. Yeah, just guess and throw it in there. And the third one, my personal favorite, if you take the rating from the existing boiler, you increase it to the next size available, and that way you know you will never have an insufficient heat callback. Sadly, there's a lot of systems out there that are already done that way or still being calculated that way. We actually have several different correct methods that are going to ensure that your customer will have an efficient and properly installed, long-lasting heating system. One of the most reliable ones, Manual J. Most of you should be familiar with this. Many of you may not own it or have gone into it. You may have just had a quick primer on it. Once you learn Manual J, it's one of the best ones you can get. Very accurate, very easy to deal with. The next one I want to talk about today is going to be if all of the heat emitters, baseboard, so on, everything works. The house currently heats okay in the coldest weather. You can measure the total baseboard or radiators or emitters, whatever happens to be there, and determine the BTU load that it'll take to distribute heat into the house. It's also known as system delivered BTUs. It's reasonably accurate for what's existing or what is already there. There's another one that I'll go into briefly. Rule of thumb method. It uses BTUs per square foot and a multiplier. So there's infinite methods. There's a ton of them. And if you look on the internet, you will find hundreds of different methods for sizing. Those three are just three basics. Manual J, in my opinion, is probably the best one there is because it's the most accurate. It also takes probably the most time out of the three of them here. Challenge yourself. Learn the proper methods to do this and use that knowledge that you learn to further, number one, your profit in the heating system world, and number two, your customers' confidence in you that you really know what's going on. So if we look at a new and a complete heating system, a lot of times it's easier to calculate that. You're starting with a clean slate or an empty house. You can go through and properly design that system to match the requirements of the building. Manual J is going to be your best way or your friend to calculate that complete system. Usually it's the most accurate. We base all heat loss on what the envelope or the building envelope is. How many windows? What are the spaces above and below? What are the spaces on the outside of the walls? How much insulation in the attic, in the floor, in the walls? What type of doors do we have? What type of glazing do we have on windows? Do we have a fireplace? In some commercial calculations, we get into how many people are the building load, because we do have a BTU rating for people in commercial spaces. There's a certain amount of BTUs given off by one person. If we have an existing system, you may or may not have a pre-installed problem to consider. You have to sort out what's there, what's already existing, determine the best course of action before you go in and just change out a boiler. Look at the whole system, See what's going on. Ask the customer if they have any problems, anything that's notable. Do you have one room that's never heated enough? Do you have one room that's too hot? Um, when it's 20 degrees out, does the system keep up? Does it heat the house effectively? Um, what, and you can measure this, the water temp of the supply and return. What's the delta T? If we have a wide delta T, let's say we're going out at 180 degrees, we're coming back at 120 degrees. We may not have enough pump to bring all of that heat around quick enough to get the BTUs out of the water, or we may be stripping all of the BTUs out because we don't have the flow. On the opposite side of that, let's say we have 180 going out and 175 coming back. We may not have enough radiation to actually take those BTUs and transfer them out to the house. But we keep an eye on that. Those are things to consider before you start into this whole mess. Um, Usually the question comes from the customer, hey, listen, I need a new boiler. Can you come over and give me a price? Well, yeah. If you're the guy that goes over there, there's three guys that go over there and two of them say, yeah, I'll just change the boiler and we'll be all set. If you're the guy that goes over there and explains to the customer, gee, let me look at what's going on here first. Let me see what you have existing, and we'll see if we can't make it better, more efficient, so that you're going to save some money. My customer. Show that customer a little bit of care. It'll go a long way with you. So if we look at system sizing, for a lot of guys, it can be kind of daunting. Hopefully when I'm done here, you're going to have a little bit of a better understanding of how to look for those answers, how to unravel that mystery of sizing. I'm going to start with a few slides here. This happens to be under Wrightsoft's Manual J. This is just a load calculation sheet. And these are the things that you're going to find there. Walls, glazing, doors, ceilings, floors, infiltration, ductwork, piping. All of these different adjustments are going to be a certain load or a certain percentage of load as far as heating or cooling goes. Now, and Manual J works for everything. It works for heating, cooling, it works for latent cooling, it works for relative humidity, all kinds of things that we can figure out that are factors in calculating or designing a system, or even just looking for the BTU load, the BTU load for that house. If we already know that everything is working well, you could do a load calculation for the entire house or the block analysis. Okay, so it's going to do the whole box only. You can get into the short forms. There's a Manual J is big, and there are a ton of different forms in it. My personal favorite is this one here, the short form. Pretty easy to go through. We got different room names. We can name it living room. In this case, they've named it system 2, system 3, and a garage. All of those loads are there. The area is there. The heating load, the cooling load, the average. What efficiencies do we have? All of those we plug into these systems. It can be bought in a magazine or a book form on paper and calculated out that way. It can also be purchased as a software. And I believe there's also an app for it, which is pretty easy. A lot of the manufacturers have apps for these things, so keep an eye on that as well. So some of the different parameters that you're going to fill out are just where are you? What zone, what system, what loads do we have? Those are going to get filled out. Just keep going through the forms. When you get done, you're going to end up with a summary sheet. At the end of that, it's going to tell you how many BTUs adjusted for everything that we've dealt with. What is that total BTU load and the net load? So if we have a 54,000, in this case, a 54,277 BTU load with a 96% AFUE furnace or boiler, we've got 52,105 BTUs available to us. That's what's going on there. So if we're replacing the entire system, the boiler, radiation, radiant flooring, I would do a room by room calculation. All right, so instead of just doing the box, do the room by room. Calculation is going to determine the correct amount of baseboard, floor piping, radiators, whatever happens to be installed in each room, making sure that that system is even, matched, that type of thing. We're only replacing and boiling. We're leaving the existing radiation, or the radiant floor happens to be there. A whole house block load will work quite well for that. So that's pretty much manual J. The next one I'm going to move on to here is going to be system delivered BTUs. This is a nice way to do a retrofit. We have to know three factors to calculate the BTUs, and it's pretty simple to do once we know those three factors. One of them is going to be the beginning temp or supply temperature. That's going to be the temperature going out of the boiler, out to the system. I don't want to deal with the boiler temperature. I want to deal with the supply temperature. Where is it going out of the boiler? Is it being mixed through a manifold? That type of thing. I want to see what's coming back to the boiler as a return temp. So we have a supply temp, a return temp, and then we need a flow rate in gallons a minute of whatever fluid is going through that system. A quick note here, there is a difference between water and some of the other heat transfer fluids. Antifreeze, for instance. If we're dealing with antifreeze, there's a little different formula for this, so be careful with that. If you've got something that is going to use antifreeze, the heat transfer isn't quite as good as water. We have to watch out for that. The water formula for system delivered BTUs, or any BTUs, is the energy, which equals 500 times the flow rate times the delta T, which is the difference in the supply and return. How do we figure that out? So if we use 100% water, we know the flow rate is 5 gallons a minute. The entering temperature is 120, or the supply temperature. The return temperature, 125. 5 degrees added to 5 gallons a minute. BTU transfer, 5 times 5 times 500. 12,500 BTUs per hour. So how did I get, what is the 500? What's 500 mean in this equation? It's the simple formula, and it's a universal formula for it. 500 is a multiplier. BTUs measured in per hour. 1 gallon of water weighs 8.33 pounds times 60 minutes in an hour. 8.33 times 60 equals 500. It actually equals 499.8. We're going to round up to that 500 and be close. Second piece of this we really need to know, sometimes the hardest to achieve or get, especially if you don't know how, is what flow rate do we have, or the system gallons per minute. How much water is flowing through the baseboard system or the total system? And finally, we need the temperature change. So we're talking about system temperature change, not equipment temperature change. And that's the effect of the BTUs transferred into the system. How many BTUs can we lose into that conditioned space? And can we measure that? So we have the water leaving the heat exchanger, subtract the water returning from the system. We can find the system delta T, or temperature change. So delta T is the difference between supply and return, or the difference between two temperatures. Measure the supply temperature on the supply or leaving side of the boiler, 10 pipe diameters away from the boiler manifold. We do that so that we get a full mix of water temperature. Ideally, I would want an immersion type thermometer, something very accurate in the water, in a well or whatever. Usually doesn't happen, so contact thermometers that most of us have for our meters, our electric meters, we can put a contact thermometer on there and check that with that. The next one we're going to look for is the return temperature. Same deal, about 10 pipe diameters away from the boiler manifold, to make sure that's mixed coming back. And then we need to calculate pump pressure in gallons per minute. So we need a pump curve. Every one of them is different. The manufacturer's curve charts are available. Most any search engine will get you there. If you want a Taco pump, there's the link to it, tacocomfort.com. 00 series cartridge circulators. I happen to punch in Takeo 007 because that's one of the most popular ones that are out there. We have Grundfos, we have all different ones. We have e-pumps now, Delta T type pumps, where we can actually set a Delta T. Those are all different factors in this. I'm not gonna complicate this too much with getting in that. You're gonna come up with a chart. That chart is gonna show you what's going on and where to find that. All right. So the second thing we're going to need is the pump pressure and feet of head. So it's the feet of pipe, the total feet of pipe for that particular loop, times 1.5 times 0.04. 1.5 is a factor um, to determine pipe resistance and the pressure drop. All right. So coils, baseboard, radiators, excess fittings, all kinds of things. That's in that 1.5 multiplier. 0.04 is typically pipe friction per 100 feet of pipe. So I just went to a nice simple one. I have a home, has 100 feet of pipe in a heating system. Formula would be 100 feet times 1.5 times 0.04. Going to equal 6 feet of head. We go to the pump curve chart. And right here on this pump curve chart, I've circled this in red here. I have a 6 feet of head that starts on this side. I have a Takeo 007, which is this curve here. We look up here. And that brings me to this point right here at about 13 and a quarter gallons per minute. So we go back to the, oops, wrong way on the slide. Nice. We go to here. Now we have the calculation 4 gallons per minute to help us calculate all those BTUs that we might be using. We have a pump pressure of 6 feet of head. The pump curve tells us we have 13.25 gallons a minute available. The system temperatures, we're going to say 177.2, return temperature of 165.4, subtract the return from the supply, determine delta T to be 11.8. So we have 500, which is our constant, 13.5 gallons a minute times 11.8 degrees. We have a total load of 77,880 BTUs. Now, that's calculated today with today's outdoor air temperature. So we should use, if we're trying to deal with this, we should use the lowest temp zone that we're living in or our house is located in. If we have a system BTUs and we're calculating them at 60 degrees outdoor, our load will be substantially different. It's going to change a lot when it's at 0 degrees outdoors. New Hampshire, our outdoor design temperature is 0 for most of the state. Southern end of the state about 5 degrees above, and northern end of the state's about 10 degrees below 0. So we're usually looking in this area somewhere around a 70-degree indoor temperature. So we have an outdoor temperature of -0 with a 70 indoor. Pretty normal. So there's no other factors in calculating that 70 degrees because we're at 70 degrees. If we're in a different zone, then we have a different multiplier for that zone. So that kind of gives us what system delivered BTUs are. Tough to go through this where we can't go back and forth on a screen. This has been a challenge to kind of put this together and make it so it's understandable and easy. But we can get through it, and you guys, what I will challenge you to do is go and learn about this a little bit. Make some notes, learn what's going on, learn how to size these things. There's different ways. Here's the way, the one we were talking about, BTUs in climate zones and a fixed number. So we're in zone 5 in New Hampshire. Happens to be zone 4 in Massachusetts. We're looking at 50 to 60 BTUs per square foot. This is kind of a rule of thumb thing that's been going on for a long, long time. This method has been around, and my caution is that if we use this method and we're dealing with a house that was already sized by this method and it had single pane windows, way below average, let's say 2 inches of insulation, nice old house. We take that old house and It's been upgraded over the years. It's got all new windows. Somebody blew in 20 inches into the ceiling. Somebody blew in R40 in the walls or foamed the walls, something like that. We can't use these figures of 50 to 60 BTUs per square foot. We're going to always oversize when we deal with that. Oversizing, probably one of the worst things we can do. I would venture to say that your boiler will do better, last longer, and give the customer better comfort if we undersize it a little bit. Um, most of the time, oversized is a very short cycle on a boiler. We might have a 2 or 3 minute cycle. Short cycling is going to just, it tears up efficiency, it overworks equipment, it makes it really difficult. One of the exceptions to sizing or for oversizing, when we size for new homes and buildings, the cost considerably less. Combi boilers, um, we can downfire and look for the domestic hot water load. That's what I'm looking for. I may need more BTUs to do my domestic hot water load than the heat capacity or the heat um, demand of the house. So what do you do in that dilemma? One thing can be a separate water heater that works well. In the event of combi boilers or heat-only boilers with a indirect water heater, we're going to use the size required for the heating, for the domestic hot water demand, and I'm going to try to downfire the firing rate for my heating capacity. On our Bosch combi boilers, we can downfire the heat load and keep the domestic hot water load at full capacity. Same for our Star heat onlys. We can have two different firing rates there. If we go into the programming on the control, we can actually turn down what our maximum heat is or heat BTU output in percentages and leave it at 100% capacity for our domestic hot water load. This way we can maintain good efficiency, longer run times when we're heating, which is what we want. We want that burner just to kind of perk along and match what heat load we might have on any given day. So it's 60 degrees outside, we're likely going to short cycle a little bit. At 30 degrees or 20 degrees outside, we should be running very nice long cycles. At 0, I might want that burner to run all the time. Burner in the pump, just constantly run. But it's going to run at a lower rate on a 60,000 BTU load than it is on 150,000 BTU. If we put 150,000 BTU boiler on a 60,000 BTU load, I'm going to overcome that load very easily, and I'm going to short cycle. It's going to cut the efficiency back. Um, the customer is going to be kind of unhappy at that point. It doesn't do well with short cycling, and we see it all the time. We see it in all these older systems. If you can go into a new boiler and size it correctly, you're going to have a really happy customer when you're done. Some of the specs that we have that we can deal with here, our heating capacity on these are our combi boilers here. We're at 135 net on the 151 combi boiler. We can give them 4 gallons a minute. In order to do that, I have to have that whole 135,000 BTUs. That's what it requires to make that. On a 60,000 BTU load, I can actually turn that back down to 36,000 BTUs. So we can turn the boiler down to 36% or 36,000 BTUs. Makes the heating side run very efficient. The domestic side becomes very effective, runs up quite well. We do have a large range of them. All the smaller lower ends on the 57, we start quite small, and those are on heat onlys. The 3 combi boilers, we start at 24,000 as our low range on our small one. We go to 36,000. So 36 on a 151 is the low, 151 is the high. If we need 151, we can put it in. If it's not using it, we can throttle that down. So this is where the efficiencies come in, when we can run these boilers to a low rate and keep them running all the time. We want to run nonstop. Just a couple of the other overviews, the 10 different models that we have on the wall boilers. I have 8 different models on a floor boiler. I go from 57,000 to 151 on a heating and 100,000 to 151 on the combi boiler. All right, so these are some basic um, rules of thumb, and these kind of hold pretty well true. PSI times 2.31 is our feet of head, our total dynamic head. If we look at gallons a minute times delta T times 500, that gets us our BTUs an hour. We went through that formula pretty easily. Pressure, linear feet of the longest circuit, usually 0.06, something like that. Proper flow for the boiler. We need to actually have what the boiler output is divided by 10,000. Boilers do have a minimum flow rate through them based on BTUs. We have to watch out for that. Our static height is, let's say it's a 3-story building. So our feet of static height determines what our proper fill pressure is. Maximum capacity of piping. This is about what pipe will carry. These numbers can be changed a little bit. If we jam a little more gallons a minute through a 1/2-inch pipe, I can do a little more than 13,000 BTUs per hour. It starts getting noisy. It starts overworking pumps, that type of thing. So these are some basics on it. Radiant floor, maximum output is about 35 BTUs a square foot. Snow melt, I kind of don't agree with this one, is 125 BTUs per square foot for snow melt. If you figure that out, if you've got a 10,000 square foot driveway and 125 BTUs a square foot, that's a pretty big boiler to take care of the load on that one. And here they're talking about estimate heat loss for a new building at 35 BTUs a square foot and an old building at 50. And we did discuss that prior. So what does that actually get us for you, the installer? What's in it? Why do you as the installer even care? Why do you want to properly size this thing? Why don't you just want to take the boiler that's in there out and put another one in, same size? Installation cost is one of them. You can save your customers some money on that. You can make yourself a little bit better profit on it. It's going to be easier to clean it and maintain it. The energy efficiency is going to be way up on a properly sized system from what was there. If you go into a house, let's say it's a house built in the 1930s, and the original boiler in it was 150,000 BTUs that somebody put in, and let's, for instance, they sized it correctly. They did everything right. Great. And then 10 years down the road or 15 years down the road, somebody decided in 1946 or something to change that boiler out, and he decided that, hey, if 130,000 is good, then 200,000 is even better. Or he got a deal on a bigger boiler, and he put that in. And then they came along and they did a few upgrades of some windows. They put some double pane windows or added some storm windows to the house, something like that. And then a few more years, the boiler crapped out, and somebody said, "Oh, 100,000, that's a pretty big boiler, but I don't want to be undersized, so I'm gonna put a bigger one in." So he went to 230. And then through the end of the 90s and into 2000, the home had a big renovation. Somebody blew in R60 in the ceiling, R40 in the walls, all brand new windows, did air sealing, made that house super tight. That BTU load that might have been 130,000 in the beginning, that somebody added to 200 and then even went bigger, might now only be about 60,000 or 70,000 BTU. So watch out what's there. Take a look at what the house is. What are you heating or cooling? What are you doing? And size your system accordingly. You're going to get a longer lasting system. You're going to get fewer callbacks. And ultimately, you are going to have a happy customer. And we all know all too well, if the customer ain't happy, ain't nobody happy. Nothing worse than putting a system in and getting a call in 2 weeks. Customer says, hey, that boiler you just put in, it's not working right. It only runs for 5 minutes and it shuts off. And you go through and you do some adjusting. And a year later, that customer calls you back and says, hey, you said this was going to be more efficient. I was going to save 20% or 15%, whatever it happened to be. Now I'm using 30% more fuel. What did you do wrong? Did you do something wrong? Is something going on there, or is there another factor involved there? If you do your homework and you properly size that system, when you sell it to the customer, you're not going to have a customer calling you back because it's not properly sized. Do it right the first time, and you will reap the benefits. That customer will forward your name on, they'll recommend you, and word of mouth recommendation is probably the best advertising that we could ever get. You can't buy it, you have to earn it. So for me, there's no substitute performing a complete heat loss, a complete and correct heat loss. It has to be done correctly. If you do it wrong, just throwing stuff at it. That's my opinion. If you're going to go into a heat loss calculation program, you're going to have to spend some money. Manual J right now is around $150. It may be a little bit less that's for the hard copy. It might be a little bit less for the electronic copy. Um, Look at your wholesalers. A lot of your wholesale companies have expert heat loss engineers there doing and helping sizing for you. And most of the time they don't charge for it. You're buying the equipment from them. That's the services they offer. I know most of the local companies in New England do it, and they do it for free. It took a long time before I needed to purchase Manual J. I have a really old Manual J book that sat in my truck for 20 something years, came in and out of my truck, and it's pretty well dilapidated. I still have it. There's not much left to it, but it's still there, and I still use it. Um, some of the other things that are here, different load calculators and different, just these links here will get you to different places. Coolcalc.com does have a free download. It's a basic program, but it's a good place to start. Okay. Um, WriteSoft is probably one of the biggest or easiest places to find Manual J. Ashray.org is also a great place to find that. So these are only little ones. Browse around the internet in your spare time. Um, and I know that in these times that spare time is awful hard to find. And these jobs, when we do a correct heat loss and a correct calculation, they take a little bit longer. You're probably going to spend an extra 2 or 3 hours bidding a job that you know nothing about. And if you know something about it and you have some basics, you can get this down. Manual J can take you as little as 10 or 15 minutes to go through Manual J. Really simple to do once you learn it. All right. Don't be afraid of it. Go learn it and go find it. Do a little bit of training, educate yourself. It only makes you better and makes you have a better um, reputation with your customers. So when we talk about training, I'm going to give you a little bit of Bosch Kool-Aid here. We have a Bosch Training Academy, E-Academy. These are a couple of the links that we have to get to BoschHeatingandCooling.com. Get you all the brochures. Bosch Pro HVAC will get you to E-Academy. So that is training.boschprohvac.com. So www.training.boschprohvac.com. If you are not an ABC dealer currently, I encourage you to do so. Our ABC program is an accredited Bosch contractor. You will go on our website. The customer can punch in their zip code, and that website or search engine in that zip code will bring up whoever's closest to that customer. Tell them what you will do, whether you just do service on Bosch equipment, whether you do service and installation, all of the above, that type of thing. So it gets you that advertising. It's also a sales program. When you sell, the more points you get, the bigger the gift card is at the end of the month or 6 months or whenever you want to redeem that. So we do give you some perks or bonus there. Also get you a separate line to tech support. So if we have on a busy day, and it's been pretty busy lately, I guess, our tech support line might have 5 or 6 calls in it at any given time. Normally you'd be number 7, but if you're an ABC contractor, there's a separate prompt to get you into the ABC line, and you go to the front. So those 5 or 6 calls that are in there are going to wait until you're done. If there's 2 ABC guys, you'll be second in line instead of 7th or 8th in line. So food for thought. Our training academy, e-academy, is a great place to sign up, take some classes. There's going to be, it's a developing system that we have now. It's a reasonably new platform for us. So we're still building, and we're building more and more, but you will find all kinds of different classes, courses, quizzes. There is a quiz for this class that will be posted in the training academy so that you can actually get continuing ed credits for that. So training.boschprohvac.com. If you're looking for brochures or other information, www.boschheatingcooling.com. You can /brochures or look for other information. Technical service bulletins, specification sheets, installation manuals, those are all there. If you're going to call Bosch Tech Support, here's the number for it. Don't be afraid to call them, but please try to be on site and try to have some information. Try to do a little bit of basic troubleshooting. Use your eyes, your ears, your brain, your hands before you call. Too often, people will be lazy or unknowing and just call with no information whatsoever. It helps to have all that information. So these are the things you need. On the job, be safe. Make sure you don't leave any job until you know that that boiler is safe. Check for carbon monoxide. You are, no matter what you do there, if you go and look at that job and it's bad, very, very bad, let's say it's a life safety issue that you see, you don't fix it or at least turn it off and inform the customer, you're the last guy that looked at it. It's likely going to come back to you. So a few more contact numbers for us. The contact info is 800-283-3787. That's all a Bosch. It's also 1-800-BUDERUS, BUDERUS. Right? Our corporate website is BoschThermotechnology.us. Our ABC is Bosch-abcpartner.com. And our e-academy is training.boschprohvac.us. Look for us on Facebook, Instagram, LinkedIn, YouTube, Twitter. We're all over the place. Feel free to use those platforms. And if you have installations that you're proud of, put them up there, post them on there. Show the world what you have and what you can do. And we'll back you up, we'll help you out. So from my end, I'm going to open it up to some questions. I hope you have some. This is my sidekick that usually sits in the office with me. His name's Bo. And he says, and I say, have a great day.